Hello, this is Mrs. Pinkerton, and we're going to go over topic 1.4, composition of mixtures. And we're going to start with elemental analysis. And what is elemental analysis? It's the elemental composition of a mixture that can be used to determine the relative amounts of the pure substance. So those can be an element or a compound that compose it. So here we have a decision tree of matter, and matter can be composed of two types. If there's only one type of substance present, we call that a pure substance, and we did that in 1.3. And if there's only one type of atom, we call it an element. And if it's more than one type, we can call that a compound. Okay, so compound, the picture below is showing you water. But it's made up of a pure substance, which is water. And then matter, if it's more than one type of substance, meaning an element or compound that's more than one, you can have a mixture, and that's what we're going to focus on here. And mixtures can branch into two types. If it's got a uniform composition, it's a homogeneous mixture. And this picture below depicts that. So you'll see that there's a uniform distribution of different compounds or compounds and elements. And if it's got an irregular composition, we call that heterogeneous. So meaning each time you take a sample of that, you're going to get a different ratio or proportion of the different elements and compounds that make up that mixture. So there's a bunch of different types of mixture problems, and so it's good to practice them because there's different ways you can be asked to find the percent of a substance in a mixture. So you really have to read the problems carefully and kind of determine how you're going to approach them. So we're going to do a couple examples here. So how do you find the mass percent of a mixture? Well, you take the mass of the substance that you're asked to find over the total mass. And anytime you find a percent, you then multiply that by 100. And here's our first example. You have a 120.32 gram sample of aluminum that's allowed to partially oxidize, and the final mass of the mixture is 120.91 grams. And then it says, what is the mass percent of the aluminum oxide? So you're given the chemical equation below here. You have aluminum, 4 aluminums, or 4 moles of aluminum, react with 3 moles of oxygen to give you 2 moles of aluminum oxide. But the key to this problem here is it tells you that a mixture results. So not everything converts into aluminum oxide. So you still have a mixture that has some of your reactants in it. And it wants you to find how much of that aluminum reacted with oxygen to form the aluminum oxide. So the first thing we know is we're given the final mass of the mixture, and we're given the initial mass of the aluminum. So if we know the final mass of the mixture and the aluminum that is originated, we know that the difference is the oxygen that reacted with it, right? Because we know that there's aluminum, and then the mass went up a little bit, so it had to have reacted with some oxygen to make aluminum oxide. So if we take the difference of that, we can find how much oxygen reacted. So 120.91 grams, which is our final mass, minus our mass of aluminum, gives us 0.59 grams of the O2, or the oxygen that was left over. And again, significant figures, remember when you're subtracting, you go to the decimal here, there's two significant figures. So that's why we get two significant figures of 0.59. So, and then it says what mass of aluminum oxide was in the mixture. So we know the oxygen. So if we know the oxygen, we can find, and we know the grams, we can find the grams of aluminum oxide. And we do that through what's called stoichiometry. And the challenge a little bit is if you haven't had chemistry before, and this is your first class of chemistry, AP Chem assumes that you've had chemistry. And we have to use stoichiometry. And we do go over stoichiometry in Unit 4.5 of AP, But you might, if you haven't had regular chemistry before, you might want to go and watch some of those 4.5 videos or jump ahead a little bit. It will really help you with these initial kind of mixture problems. There's some great Michael Faribault videos or Jeremy Krug videos that students like to use. So just make sure that you review that if this is not comfortable for you or you don't have a lot of exposure to it. So we can't go straight from grams of oxygen to grams of aluminum oxide. We have to first go to moles. So anytime we want to convert from one compound to another or one element to another compound, we have to convert to moles of oxygen. And then we have to use what we're called the mole ratio to find the moles of our aluminum oxide. And then we can find the grams. So that's how we're going to approach this problem. So we know that 0.59 grams of oxygen reacted. And I put that over 1. And I have to convert that to moles. So in order to do that, I find the molar mass. So for every 1 mole of oxygen, I have 32 grams of oxygen. So there's each oxygen is 16 grams on the periodic table. And I cancel my grams. And now I'm left with moles of oxygen, but I want to get rid of moles of oxygen, so I put that in my denominator. And I want to convert to moles of aluminum oxide. And I can do that by looking at my balanced equation. And my balanced equation is like a recipe, and it tells me that I need 4 moles of aluminum, that's what this coefficient tells me, plus 3 moles of oxygen. And if I have that ratio, it will give me 2 moles of aluminum oxide. So I know that for every 3 moles of oxygen here, I can make 2 moles of aluminum oxide. And that's how I convert from moles of oxygen to moles of aluminum oxide by using the coefficients of my balanced equation. But I don't want moles of aluminum oxide. I want grams of aluminum oxide, and that's my molar mass again. That's how I convert from grams to moles. And I know that for every 1 mole, if I look on my periodic table and add 2 aluminums plus 3 oxygens, I will get 101.948 grams. Let me erase that and write that a little better. 101.948 grams of aluminum oxide. Okay, so then my moles cancel out and I'm left with grams. So I take 0.59 divided by 32, multiply that by 2, divide by 3, and then multiply by 101.948. I need to use 2 significant figures, and I get 1.3 grams of aluminum oxide. Okay, so I found my grams of aluminum oxide, so now I can find my mass percent. I take my substance, which is aluminum oxide, and I divide it by my total mass, which was 120.91. I multiply that by 100, and I get 1.1% is aluminum oxide. Okay, now pause this video and try the your turn example. So this your turn example is a little different than what we've done above because you're not given a chemical equation. It just says you have a 5-gram sample of a mixture, so that's your total mass, and 1.5 grams of it is calcium, and it wants you to find the percent that's calcium carbonate. So the mixture, it says, contains calcium carbonate and silicon dioxide, and how am I going to find what percent of that is calcium carbonate? Well, I know to find the mass percent that I have to take my grams of calcium carbonate over my total mass of my sample and multiply that by 100. So it's asking me, how can I find the number that goes there? Well, my clue here is I'm given 1.5 grams of calcium. And since my mixture only contains calcium carbonate and silicon dioxide, I know that all of my calcium has to have come from my calcium carbonate. So I can convert my grams always when I want to go from an element to a compound or anything else. I have to convert to moles first, and then I can convert back into grams. So I'm going to start with what I'm given, which is 1.5 grams of calcium. I'm going to put that over 1, and I have to use the molar mass, convert to moles of calcium. And if I look on the periodic table, I can see that 1 calcium is 40.1 grams. So now my grams cancel out, and if I divide, I get moles of calcium. But I want calcium carbonate, and I know all of my calcium is coming from here. And so I know just from the chemical formula that for every 1 mole of calcium, and I'm putting moles of calcium in my denominator because I want those to cancel out, I have 1 mole of calcium carbonate, right? Because there's 1 calcium in every 1 calcium carbonate. So now my moles of calcium cancel out, and I'm left with moles of calcium carbonate. But now I need to get to grams, so I need to find the molar mass. So I'm going to put moles of calcium carbonate on the bottom. So for every 1 mole of calcium carbonate, if I go to the periodic table and I add calcium's mass plus carbon's mass plus 3 oxygen mass, I will get 100.1 grams. 100.1 grams of calcium carbonate. So now what you're going to do is take 1.5, divide by 40.1, and we can ignore the ones and just multiply by 100.1 grams, and that will give you 3.74 grams of calcium carbonate. Yay, I found that number, so now I can plug it in here to get my percent. So I'm going to erase that question mark. I'm going to put 3.74 grams times 100. Well, 3.74 grams divided by 5 times 100, and it's going to give me 74.8% calcium carbonate. Okay. So make sure you practice these and try a bunch of different types of problems. That's the best way to get comfortable with this.